All right, this is the review I have for the Chapter 2 test. Reminder to also look back at the AP problems that we did, the related rates problems in the notes. These are all no calculator derivatives. All right, find the derivatives. So these are all of our derivative rules. Remember, sometimes it helps to rewrite roots as exponents. So y prime equals 5/7 times x to the 5/7 minus 1 is negative 2/7. And then we want to rewrite that as 5/7 x to the 2/7. Or you could write 7th root of x squared in the denominator. For the next one, f of theta is equal to theta to the 4/3. So f prime of theta, make sure you're not just writing equals when you're doing the derivative, f prime of theta equals 4/3 times theta to the 4/3 minus 1 or minus 3/3 is 1/3. And I don't need to rewrite that at all. That's my final answer. Y equals the 6th root of e to the 4th. Now be careful, I am trying to trick you on this one. E is an irrational number. It's not the variable. If it were the variable, we'd have to say like y of e or something. So this is a constant. Y prime is equal to 0. For f, pi to the 4th is a constant, but x to the 4th is a variable. So f prime of x. So x to the 4th will become 4x cubed. So I'm going to make it 4 pi to the 4th. And then x cubed. And there's nothing to rewrite there. For this one, e cubed and pi, those are both constants. So y prime or dy dx will be 3/2. I'm going to put e cubed and pi up here. X to the 3/2 minus 2/2 is 1/2, positive, so I will leave my answer like that. For this next one, you could either chain rule this, or you could say f is 5 to the 17th, whatever that is, times x to the power to a power is 34. I think this might be easier than doing chain rule. So I'm going to say f prime of x is equal to 34 times 5 to the 17th times x to the 33rd. In my opinion, that's better, more efficient than doing chain rule here. For the next one, it's important to know the difference between sine of 5 theta squared to the 3rd and sine to the 3rd. So this one, the sine is not being cubed, the angle is. So we could make this 5 to the 3rd is 125, theta to the 6th. This is much better to look at. So g prime. So I do still need to do chain rule here, but not as much chain rule as I would have to for the original. So the outer function here is sine of something. And then we have 125 theta to the 6th. So g prime of theta, the derivative of sine is cosine. And it's not just theta in here, it's the expression. So this is like saying f prime of u times u prime. So here's f prime of u times u prime. So the derivative of 125 theta to the 6th is 6 times 125. 12, 15, that's 750. Theta to the 5th. I'm not going to rewrite putting things out in front because there's just not much room here. I want to do the same thing I did for number 17 onto this one. So this is the sine of 5 to the 17th times theta to the 34th. So y prime would equal the derivative of sine is cosine of this whole thing. So f prime of u times u prime. So what is the derivative of this? It's 34 times 5 to the 17th times theta to the 33rd. For number 9, nothing to simplify in here. So the outer function is cosine. The inner is this part here. So h prime of x. The derivative of cosine is negative sine of pi to the fourth x to the fourth. And the derivative of that is 4 pi to the fourth x to the third. For number 10, careful on 10 here. So you don't want to just say the derivative of t is 1, the derivative of cosine is negative sine. Remember, you have to product rule right here. So this is product. Anytime you're multiplying two expressions with variables in them, you have to do this. And then this is just a trig function. So product rule first. Remember, the order that you take derivatives doesn't matter. So take the derivative of one, leave the other alone. Add to that the derivative of the other, leave the opposite alone. So I'm going to do first times derivative of the second plus second times derivative of the first over here plus 3 cosine t, derivative of that term. I will clean this up a little bit because I see some like terms I can combine. So x prime of t is equal to, let's make this negative t sine t plus cosine t plus 3 cosine t is plus 4 cosine t. Now on this one, the 4 is on the cosine. So we have something to the fourth. That's the first thing to do. And then the next function is cosine of something. And then the innermost function is 4 pi x. So when we find y prime, first thing to do is take care of the power rule. So it'll be 4 cosine of all this. Cosines to the third power. So 4 cosine cubed of all that. Multiply that by the derivative of cosine, which is negative sine, still of u, 4 pi x. Multiply that by u prime. Derivative of 4 pi x is just 4 pi. So all of this is multiplied together. I'll clean it up just a little bit. 4 times negative 1 times 4 pi is negative 16 pi. Cosine to the third of 4 pi x times sine of 4 pi x. Because we have multiple choice problems, there's no required amount of simplifying. It's just about being able to simplify to find your answer amongst the answers given. All right, for this one, now the 4 is on the angle. So why don't we clean this up first? 4 to the fourth. Let's see. I know 4 to the third is 64 times 4. That's 16, 24, it's 256. Pi the fourth, x to the fourth. That just makes it so I don't have to chain as much. All right, so y prime is, so the outermost function is cosine, so negative sine of u. Times u prime. So this is all just a constant. It's going to be 4 times 256. You don't have to simplify this stuff. I just think it's kind of good to do. So 24, that's 20 plus 2 is 22. 4 times 2 is 8 plus 2 is 10. So 1024 pi to the fourth. I was doing that because this becomes 4x cubed. So 4 times 256 is this. Pi to the fourth, x to the third. All right, let's take a look at number 13. So same idea. I'm not going to figure out 4 to the 8th. I'm just going to write it as 4 to the 8th, pi to the 8th, x to the 8th. So f prime of x is equal to the derivative of cosine is negative sine of u times the derivative of u, 8 times 4 to the 8th times pi to the 8th times x to the 7th. right, this one, I'm going to clean this up. It's cotangent of pi to the ninth t to the ninth. So g prime, the derivative of cotangent is negative, because it starts with a c, negative cosecant squared of u times u prime, which is 9 pi to the ninth t to the eighth. Cosecant to the ninth of all this, so the outermost function is something to the ninth, and then we have a cosecant of something, and then we have theta to the fifth. Actually, I want to rewrite that. Theta is the variable. So again, trying to be tricky here. Pi to the third is the constant. So I like to write that first. All right, so y prime is equal to, power rule first, 9 cosecant to the eighth, and the angle is still all of this stuff, except I don't like theta to the fifth, pi to the third, so I'm going to say pi to the third. Theta to the fifth, that does not matter, because we know that multiplication is commutative. The derivative of cosecant, that starts with a c, so it's negative. Derivative of cosecant is cosecant cotangent. It's cosecant cotangent of this angle still. I am able to go off my paper, so sorry, there's not much room here. And I have to multiply by the derivative of this, so that's going to be 5 pi to the third, theta to the fourth. I am not cleaning that up. I could if I really had to. You can multiply this, this, and this together, and then put your trig stuff. Actually, okay, fine. I will, actually. There's quite a bit to simplify, so why not? All right, so that's y prime of theta equals 9 times negative 1 times 5. This is all being multiplied together, so I can do that. So that's negative 45 pi to the third, theta to the fourth. So that's this times this times this. Then we have cosecant to the eighth times cosecant. So that's cosecant to the ninth, pi cubed theta to the fifth. And there's just a little cotangent of pi to the third, theta to the fifth. Okay, let's see. Notice again, 16 and 17, where is the 8? Here it's on the tangent. So we have something to the 8th, and then we have tangent of something, and then we have x to the third. So y prime is equal to 8 tangent to the 7th of u times the derivative of tangent is secant squared of u times the derivative of x to the third, which is 3x squared. Not simplifying, leaving that alone. This one, I should say, well, this might as well just be the tangent of x to the 24th. So you have tangent of something, and then you have x to the 24th. So y prime, or dy dx, the derivative of tangent is secant squared of u times u prime, which is 24x to the 23rd. For the next one, this is a constant. There's nothing crazy happening on this. This is just g prime of x. The derivative of a constant is 0. The derivative of the next term is pi times 1. The derivative of cosine is negative sign, so I'm going to write minus pi sine x. There's no chain rule happening on that one. For this one, I think that says e squared. I'm going to treat it like an e squared. It's just a constant anyway. So h prime of x, the derivative of e is 0. That's a constant. The derivative of pi e squared x just becomes pi e squared. The derivative of e cosine pi, that's a number. So that's derivative 0. So this is my derivative. What if we don't have equations? This is, AP Test loves to give us questions like this. Find the derivative, like, do you really know the chain rule? So this goes back to like f prime of u times u prime. Okay. First off, I need a quotient rule. So first and foremost, this is quotient rule. And then I have to remember to chain as I go along. So y prime of t is low d high. So g of t times the derivative of the top. So that'll be f prime of u times u prime minus high d low. That's just g prime of t. The derivative of t is just 1, so that's why I don't have to think about chain rule. All over low, low. So I'm going to write g of t squared. Now the AP test likes to have us, find y prime of 5, and maybe they give us a table where we're like plugging 5 into these values and seeing what happens. All right, let's look at this one. Okay, so again, we need, we need quotient rule, and we'll have to chain as we're taking derivatives. So h prime of x is equal to low d high, so f of 5x times the derivative of this upper part. So the derivative of the upper part is power rule first, so it'll become 2 g of x, times the derivative of the inside, which is g prime of x. So this one was something squared and then g of x. Low d high minus high d low, f prime of u times u prime, all over low, low. I like using brackets when I have parentheses involved. It's like same thing here, but it doesn't matter. All right, what about, let's see. Hold on. I had a really good pattern going, and this is going to bother me. So let's make this one blue. Blue. And let's make this one red. I was trying to make these so that, so that they weren't, I didn't want to delete it. So they weren't the same color on top of each other. So there we go, better. Okay, this one's going to be green. So f prime, c is a constant. This is a number. T is the function name. X is the input. So the constant is along for the ride. This should just be c times t prime of x. There's no chain rule happening. Oh, no, wait, sorry. Maybe this isn't a constant. Maybe that's a function. It's not really that clear, is it? Okay, so let's treat that as a function. We have c of something, and then we have t of something, and then we have x. So c prime of t of x multiplied by t prime of x. Technically times 1. I don't have to write that, though. All right, and then 23. So f of g of t of x. So we have f on the outside, and then we have g, and then we have t of x. So h prime of x is f prime of everything inside it times g prime of everything inside g times t prime. It's like those little Russian nesting dolls, whatever they're called. You're working from the outside in, and everything that was inside stays along when you take the derivative of something. All right, what about this side? Now, here's one where I don't want to expand this out to the fifth, so I'm trying to force you into chain rule, but also it's product rule first. Product rule, and within product rule, we'll have to chain. So f prime of x is first times derivative of the second. That'll be 5 times 3x plus 1 to the fourth times the derivative of 3x plus 1. First times derivative of the second plus second times derivative of the first, which is just 4. Let's clean this up a bit. 4x times 5 is 20x times 3 is 60x times 3x plus 1 to the fourth plus 4 times 3x plus 1 to the fifth. Grading your chain rule packets, I noticed you guys don't like to factor out a GCF. I think it's worth practicing. So I am going to factor out a 4 times 3x plus 1 to the fourth. And what would that leave me with? 60 divided by 4 is 15x. This cancels out completely. Plus the 4's cancel out. We're left with 3x plus 1 to the first power. So that's 4 times 3x plus 1 to the fourth. And then this cleans up to 18x plus 1. It's a skill you need to have because it could be that the multiple choice answer has been simplified that far, or it could be that you're trying to set f prime of x equal to 0 and solve it, and it's much easier to solve in this form than any of the others if you don't have a calculator. G of x is equal to pi e to the fourth. I know e is not a variable because the input is x. So this is a number. G prime is equal to 0. That's easy. All right, what about 26? H of theta is, we need a product rule right here. And then we'll take the derivative of this term. H prime of theta is first times derivative of the second plus second times derivative of the first minus the derivative of this minus 5 times cosine theta. Because the angles were theta, they weren't 2 theta, 3 theta, whatever. They have derivatives of 1. We do not have to chain rule any of that. So I'm just going to clean it up a bit. Let's make it negative theta sine theta. And then 1 cosine minus 5 cosine is minus 4 cosine theta. You could factor in negative out if you want. I'm not going to. Okay, let's see. Position, velocity, acceleration. So the position of a particle is given by x of t equals this. Does the velocity increase or decrease at time equals 3? If you're trying to decide is something increasing or decreasing, you look at that thing's derivative. So is v of t increasing or decreasing? I need to figure out v prime of t. And v prime of t is the same as a of t. Is a of t positive or negative? So increase would be v prime is greater than 0. Decrease would be v prime is less than 0. To find v prime, I need to first find v. So v of t is equal to 4t to the third plus 0. A of t, or v prime, is equal to 12t squared. At t equals 3, a of 3 is equal to 12 times 9, which is greater than 0. So I know that v of t is increasing at t equals 3 because all I have to say is a of 3 greater than 0. It's good to show the work down here, but that's it. That's all you have to write. Does acceleration increase or decrease at t equals 3? So this is the same exact type of question, but if you want to know about acceleration, you need a prime of t. So a prime of t is 24t. We're looking at t equals 3. A prime of 3 is 24 times 3. It doesn't matter what number that is. It's just the fact that it's greater than 0. So a of t is increasing at t equals 3 because a prime of t is greater than 0. You could have said v prime back here. V prime of 3 greater than 0. That's fine too. The derivative of acceleration is jerk, I believe, but I just didn't want to do j of t. All right, now speed. We've had this question quite a bit earlier on in the chapter. Does speed increase or decrease? The speed will be increasing if v of t and a of t are the same sign. And it'll be decreasing if they're opposite signs. So v of 3, we already calculated. Oh, no, I didn't calculate that. V of 3 is equal to 4 times 3 to the third. which is greater than 0. A of 3 I did calculate. It was equal to 12 times 9, which is also greater than 0. So this means that the speed is increasing at t equals 3. And my justification is because v of 3 is greater than 0 and a of 3 is greater than 0. The velocity is in the positive direction and the acceleration is making the velocity increase in the positive direction. So you are going faster. If they're working against each other, if they're opposite signs, the speed would be slowing down. Oh, that was the last question. All right, remember, you had an AP related rates and implicit worksheet. This will be very helpful to either work through again or at least just go through, watch the video, look through your answers again. It could even be that one of these questions looks very familiar on our test. So that's my other incentive to get you to look at this. Also, we have an AP classroom review, which will help you with multiple choice.